All right, greetings, grade 12s. We are starting with the last type of sequence that you need to know, and that is geometric sequences. So far, we have covered arithmetic sequences, quadratic sequences, and now we are dealing with something that is very new, and that is geometric sequences. And I will take my time just explaining this topic thoroughly. Okay, so the first thing that we need to know, it is the general formula of a geometric sequence. Okay, and you'd realize that this geometric sequence is actually quite related to exponents. So if you understand exponents, it's easier to understand how the geometric sequence works. Okay, now let's look. This is the general formula. The general formula is given by Tn equals to Arn minus 1. Okay, Tn in this case stands for the term, A stands for the first term, R stands, now we no longer deal with the common difference, but it stands for the common ratio. N, as always, stands for the number of terms. Okay. We will notice that any geometric sequence has the following form. Okay, it has the following general form. The first term, you would notice that, as in all other cases, is given by A. The second term is given by AR. The third term is given by AR squared. The fourth term is given by AR cubed. The fifth term is given by AR 4. The sixth term is given by AR 5. Notice what's happening. We are saying you are taking this, and this is how we got this, because some of you think that you are picking that from the sky. T1, wherever we see N, we put 1. So this is A R1 minus 1. So this is T1 equals to A, 1 minus 1 is 0, and we know that any number to the exponent 0 is what? Is 1, and that's how we got A. The same logic we followed when we got this. We didn't just pick that from the sky, we substituted in the general formula to say wherever we see N, we put 2, and here is N, we put 2. So that's 2 minus 1, and there's an R there, so that is 2 equals to AR to the power of 1, which is just the same as AR. Okay, all the way to Tn equals to ARn minus 1. In calculations, you will appreciate that what I'm showing you now will be extremely important when you calculate missing terms. You need to know how a geometric sequence works. Okay, and let me just continue giving you notes there. When we calculate the common ratio, we always say, and it's given by R, we always say the next term divided by the previous term. An example of that, if I was given a sequence of T1, T2, T3, and I wanted to find the common ratio here, I would say T2 divided by T1. Okay, it holds that for any geometric sequence, it holds that R equals to Tn plus 1 all over Tn, which equals to Tn plus 2 all over Tn plus 1. Okay, an example of this would be T2 over T1 equals to T3 over T2, and all of this relationship is going to be important when we start dealing with calculations. Okay, and all of this will give you R, Okay, let us apply now what we have learned, and you will begin to understand how does everything work. They say find the sixth term of the pattern. Well, the first thing they didn't tell me what type of sequence is this. So the first step here is to determine the type of sequence. Okay, we are not told that it is a geometric sequence. We are not told that it's an arithmetic sequence or quadratic. So we are just told that this is a sequence. So we will say 2, 6, 18. So first we will start with subtraction. 4, 6 minus 2 is 4. 18 minus 6 is 12. So this is not, it is not arithmetic. Okay, it is not arithmetic. Let us try to see if it's geometric. Okay, let us see if it's geometric. Let us say now T2 divided by T1, that is 6 divided by 2, which is 3. And let us try it again here. T3 divided by T2, it's 18 divided by 6, and it gives you 3. So we are in luck. We have a constant there, and that is the common ratio that we are dealing with. Now we have ascertained that this is a common this is a geometric sequence. Okay, it's a geometric sequence. What you will notice with a geometric sequence is that with an arithmetic sequence, if we have 1, 2, 3, 4, 5, we are adding 1. Okay, but in this case, if you notice what's happening in the geometric sequence 2, 6, 18, for us to go from here to here, we are multiplying by 3. So with a geometric sequence, we are multiplying, and of course with an arithmetic and a quadratic, we are adding. So that is an interesting point to note. All right, now if you didn't know how to calculate the common ratio, you would just establish a pattern here to say 2, 6, 18. Okay, so you would notice that from here to here, in order for us to go there, we multiplied by 3. From here to here, we said 6 times 3, it is 18. Okay, 6 times 3, it is 18. 6 times 3, it is 18. And of course, we would want to say, okay, what is 18? What is 18 times 6 times 3 rather? All right, just get my calculator so that we can be fast about the matter. I am not gonna think things through. So 18 times 3, there we realize that it is 54. Then we take that same 54 and say 54 times 3, and we get 162, and we get that we say 162 times 3, it is 486. Okay, so if you didn't know how to use the geometric sequence, you just establish how is the pattern evolving, and then you'd find out that of course your sixth term there, it is 486. However, we are in grade 12, we have a better approach, and the better approach is first we must find out what is the general term, and after finding out the general term, we will from the general term be able to determine what is our sixth term. So first I want to state step 2. I want to state the first term as the first. Okay, state the first term. T1 equals to A, which equals to 2. Very easy. And then I want to find my common ratio. Remember, we have found out that this is a geometric sequence, so we will say T2 divided by T1, and this is 6 divided by 2, which is 3. Guys, it is important for you to show that this is especially if they write it, they say the sequence, you must first state this is an arithmetic sequence, this is a geometric sequence, this is a what type of sequence. So that is very much important. All right, and then we want to find our general term. We know the formula is Tn equals to ARn minus 1. Therefore, our first term is 2. Our common ratio is 3, so this is our general term. All right, so now we can be able to find what is T6 by mere substitution. So this is 2, 3, and wherever we see n, we put 6, so that is 6 minus 1, and that of course gives us 486. That is how you would find the next term. We are now on example 2 of geometric sequences, and this is case 2 of geometric sequences. So now let us look at this, and for purposes of us not wasting time, I will say this is a geometric sequence so that we don't waste time trying to figure out what type of sequence are we dealing with. The question there says, which term of the geometric sequence, and this is the sequence, is equal to 4 over 25. So we are trying to find what, guys? We are trying to find Tn, and when we find Tn, the value of Tn must be 4 over 25 over 125 rather, and that means that in actual fact we are looking for n. Thus the first thing that we must find then, it is the general term, and the general term will lead us to solving for n. A very interesting process that I will expose you to. So let's start here. So you have 20 minus 4 and 4 over 5. I've told you that already this is a geometric sequence. If it is not, if they just said sequence, you must determine that is it a geometric sequence or not. The first step, guys, is that we want to write what is our first term, and as we notice here, our first term is 20. So that's okay and well. The second thing that we want to do is that we want to find out what is our common ratio. Remember, we are going to say the next term divided by the previous term, T2 over T1, T3 over T2, and so forth. So this is minus 4 divided by 20, and we get 4 into 4 goes how many times? It goes once. And then 4 into 20 goes how many times, guys? It goes 5 times. Okay, so now we have our common ratio. We can then find our general term, Tn equals to ARn minus 1. And well, our first term was 20. Our common ratio was minus 1 over 5. And of course, this is n minus 1. That is the value of Tn. So we have done this step. We have found this step. And this step should lead us to this step by substituting this. And I know I said a lot. Just follow what I'm trying to say. All right. So we are told that the value of the term is 4 over 25 over 125. And our duty, therefore, is to solve for what is the value of n. Okay. So then this is 20 equals to minus 1 over 5 n minus 1. Our task then would be to remove this here. Okay, and the way that we can do this is to apply the multiplicative inverse, or simply put, we can just divide by 2, which is the same as divide by 20 divided by 20, which is the same as multiplying by 1 over 20. So that is what we are gonna do. You see, if you are a learner who's used to this issue of transposing, your term transposing doesn't work here, because to begin with, it is a wrong terminology. Okay, so anyway, we are not there. The 20 and the 20 will give us 1, so that we are left with minus 1 over 5 and minus 1. And this side we have 4 over 125 divided by 20. Okay, this is the same as over 1. All right, so this is minus 1 over 5 and minus 1, 4 over 125. This can be written as times 1 over 20. Okay, so 4 times 1 is 4. 20 times 125 is actually 2,500. Okay, so now we are gonna then say, in this scenario, how many times does 4 go into 4? It goes once. And I'm gonna type here on my calculator and say what is 2,500 divided by 4. Well, it gives us 625. And of course, this is minus 1 over 5 and minus 1. Well, me and you are smart. We know that this can be written as 5 to the exponent 4. Okay, can be written as 5 to the exponent 4. So this can be rewritten as 1 over 5 to the exponent 4, because 5 to the exponent 4 is the same as 625. Okay, somebody can see what I'm trying to do. I'm trying to make the bases the same so that I can equate the exponents. Okay, so this is minus 1 over 5 and minus 1. All right, this statement here, 1 to the exponent 4 is the same as 1, meaning this 1, I can rewrite it as 1 to the exponent 4, and this is 5 to the exponent 4 minus 1 over 5 and minus 1. Okay, the statement here can be rewritten as 1 over 5 to the exponent 4, and this is minus 1 over 5 and minus 1. Can you see what I'm doing here? I have made the bases to be the same. Now the issue that I have is the issue of negative. But what I know is that 2 squared is equals to 4 and minus 2 squared equals to 4. 2 squared, 2 to the exponent 4 is equals to 16. I hope. Yeah, it is equals to 16. Yeah, it is equals to 16, and minus 2 to the exponent 4 is equals to 16. So what you notice is that when we square with an even number, we'll always have a positive answer. Okay, so there's no difference, meaning if I write this as minus 1 over 5, the answer that I get here will be the same as the answer that I get there. I have not changed anything. Okay, and the reason I am writing it that way is because, again, I am trying to make the bases to be what? The same. So this is equals to minus 1 over 5 and minus 1. Therefore, the bases are the same. Therefore, what can we do? We equate the exponents. Therefore, n is equals to 4 plus 1 and n is equals to 5. Therefore, T5 is equals to what, guys? You said it is equals to 4 over 125, and that is how we get that beautiful answer. We look into the third part of geometric sequences, and this is just example 3, continuing from example 1 and 2. It says determine the geometric sequence. In other words, they didn't give us the geometric sequence. We must find what is the geometric sequence, and generally if you just find the first 3 terms, that should suffice. So we are looking for T1, T2 and T3. Okay, so what did they give us? Well, they gave us the second term. They told us that the second term is 1 over 9, and also they gave us the sixth term, and they told us that the sixth term, it is 1 over 729. Okay, so let us just state, and this is how we usually approach the question. Just state what you are given. Well, we are given that the second term is 1 over 9. Okay, but we know in general that T2 is equals to AR. So since that is the case, this implies, and this is the sign for this implies. All right, many learners write 2 equals to signs. That's wrong. This is the symbol for this implies. This implies that AR is equals to 1 over 9. Okay, because I can solve that further, I just call this equation 1. All right, now let's see what else are we given. We are given the sixth term, and we are told that the sixth term is 1 over 729. Okay, and what do we know? We know that T6 is the same as AR to the exponent 5. That's what we know. So this therefore implies that AR to the exponent 5 is equals to 1 over 729. Because I can't solve that further, I call that equation 2. From here, I want to apply the elimination method. Substitution is harder to work with here, so we will apply the elimination method where we can remove one variable, and the ideal variable to remove here is a. So what I will say equation 2 divided by equation 1. So equation 2, AR to the exponent 5 will be divided by the first term, but the first equation, which is AR, and this is equals to 1 over 729, this part here, divided by 1 over 9. Okay, so basically you're just putting things as they are. What is on the left hand side goes to the left hand side, what is on the right hand side goes to the right hand side. So this is AR to the exponent 5 times 1 over AR. This is 1 over 729 multiplied by 9 over 1. So this is AR to the exponent 5 divided by, this is the same as over 1, divided by AR. This is 9 over 729, 9 divided by 729. Okay, we're gonna continue from there. Now notice what happens here. The A and the A cancels out, and we remember a property here that is essential. When the bases are the same during division, we subtract the exponent. Okay, we subtract the exponents. All right, so what's going to happen here is we are going to say R, this is the same as 1. R is R to the exponent 5 minus 1. And then now we are going to ask ourselves a critical question. How many times does 9 go into 9? It goes once. And how many times does 9 go into 729? It goes 81 times. That is critical, guys. So therefore this is R to the exponent 4 is equals to 1 over 81. To square root with an even number, you must have two solutions. So even number means you get two solutions, and if we square root with an odd number, say your 1, your 3, we have one solution. So whatever answer that we get here must be plus minus. Okay, so therefore this is R equals to, and this was over 81, sorry about that, over 81. This is plus minus 1 over 3. Okay, and this is exponent 4 there. Okay, I hope you can see past my mistakes. So we have found the value of our R. Our R can either be 1 over 3 or our R can be minus 1 over 3. Very important. And I will divide this page like this so that we see how are we gonna apply this. All right, now let's see, guys. We have solved for R. Our next task now is to solve for A. So I will call this, for my purposes, I will call this equation 3. I will call this equation 3. So this is the case where if R equals to 1 over 3, so we will then say substitute equation 3, and because on your slides we chose to substitute it on equation 1, we will stick to that. We will substitute, although you can substitute in equation 2, we'll substitute it into equation 1. Well, let us see what's happening. We have A, we are looking for that. R, we do know what it is, and all of this, guys, is equals to 1 over 9. Okay, 1 over 9. So therefore, if we now apply the multiplicative inverse here, this is A over 3 equals to 1 over 9. We can apply the multiplicative inverse by multiplying by 3 over 1 by multiplying by 3 over 1. This and this cancels out. A is equals to 3 over 9. Therefore, lo and behold, 3 into 3 goes once, and 3 into 9 goes 3 times. Lo and behold, we have found our first term. We can find our second term by knowing that this is AR, and we know here we must say 1 over 3 multiplied by 1 over 3 so that we get 1 over 9. And then of course T3 equals to AR squared. This is 1 over 3 over 1 over 3 squared. And of course it is easy for us to see from this case that this will be 1 over 27. Therefore we have our sequence there, which is 1 over 3, 1 over 9, and of course 1 over 27. Very interesting stuff here, guys. Okay, let's go into the second case, because here we were squaring with an even number, we got two solutions. So we cannot just stop there. If it was an odd number, that's where we were going to stop. But because we are squaring with an even number, we must have two solutions. Okay, so we will say if r equals to minus 1 over 3, same procedure, substitute 3 in 1. And of course, instead of us now having positive, we'll just have negative 1 over 3 equals to 1 over 9. And then this is negative a over 3, which equals to 1 over 9. And of course, here the value of a, we really can't labor that much on this, is equals to minus 1 over 3. And with proper solving, we will then find out, and this will be your little homework here, we will find out that the sequence is minus 1 over 3, 1 over 9, and negative 1 over 27. Let us look into the last part. Given that T4 is x minus 4, T5 is x plus 2, and T6 is 3x plus 1. I always like stating what I'm given, guys. They said T4 is x minus 4, T5 is x plus 2, T6 is 3x plus 1. I always like stating what I'm given. Okay. And we are told here that they are geometric. That is very important. You know, they just gave you like that and didn't state if they're geometric, arithmetic, quadratic. You can't solve that. You can't solve that because you have nothing to work with. So at least they told us that they're geometric. We are told that we must determine the value of x. Well, since they're geometric, what I know is for any geometric sequence, the following holds. So I'm going to say T5 divided by T4. Notice how I'm doing it. Then it's T6 divided by T5, because this is T4, T5, T6. So T5 divided by T4, T6 divided by T5. All right. Do we know what is T5? Yes, we do. It's x plus 2. Do we know what is T4? Yes, we do. It's x minus 4. Do we know what is T6? It is 3x plus 1. Do we know what is T5? It is x plus 2. Okay. Then here we cross multiply, guys. Cross multiply. Basic grade 8. So that we have x minus 4, 3x plus 1 equals to x plus 2, x plus 2. So here the answer that we are going to get is 3x squared minus 11x minus 4. Okay. Very, very simple stuff there. It's x squared plus 4x plus 4. Okay, all right. Now you can come to an issue of grouping. Well, this is 2x. If this is transposed, it will be negative. So this is 3x squared minus x squared. It gives us 2x squared. Okay. Okay, let's come to this one now. If this is transposed, it will be negative. Not transposed is if you apply the additive inverse. I hate the word transpose and I'm using it so much. Okay. If you apply the additive inverse, you will get negative 4. So that if you say negative 11x, negative 4x, you will get negative 15x. If this, you apply the additive inverse, it is negative 4 minus 4, and the answer should be minus 8. If you don't believe me, please try to do that on your own. I skipped a lot of steps there. I am not recommending that you skip steps, but I did skip a lot of steps there. Then we want to factorize this. All right, that's 2x and x. That's plus 1 and minus 8. Therefore, x can either be minus 1 over 2 or x can be equals to 8. All right, that's simple. That's simple. All right, let us look at the second question. It says then we must determine the sequence, and again, as we did in the previous question, we will also follow the same pattern. So what I want to do first, I will say if x equals to minus 1 over 2. Now I want to write T4 as an actual value. Remember here T4 was given as x minus 4. So wherever I see x now, I will put minus 1 over 2 minus 4. and if you work that through, you will see. And I'll just show you with 1 in case you forgot. Our LCM there is 2. 2 into 2 goes once, multiplied by that is -1. This is the same as over 1. This 1 into 2 goes how many times? It goes twice, multiplied by -4, it's -8, so that you have -9 over 2. I'm not going to do that with the rest of the things. I think you got the gist of the story. T5 is x plus 2, so that is 1 minus 1 over 2 plus 2, and of course our answer should be 3 over 2, applying the same method that we did there of the issues of LCM. T6 is given as 3x plus 1, so wherever we see x, we put -1 over 2, and that is of course plus 1, and if you solve that, that should be -1 over 2. All right, I hope that makes sense to you, and I really applied the issues. This is basic solving, guys. If you don't know how to do it, just type it on your calculator. You will get what I'm saying. Now, if you want to determine the sequence, we need A and we need R. Those are the essential things. Okay, we need A and we need R, and it tells you that somewhere we're going to apply simultaneous equations. But at least with R, I can just say T6 over T5 because I have the values already. So basically I can then say in this case, well, what do I have? T6 is -1 over 2, and then T5 is 3 over 2. Then this is -1 over 2 multiplied by 2 over 3, and of course your answer there should be -1 over 3. At least we have our value of R. All right, then we are left with determining what is the value of A. We can use T6. Well, we know that T6 is T6 equals to -1 over 2. That is what we got there. But me and you know that T6 is the same as AR to the exponent 5. So therefore, this implies that AR to the exponent 5 equals to -1 over 2. Well, we have found what is R. R is -1 over 3. -1 over 3 to the exponent 5 equals to -1 over 2. And with simplification, because I don't have a calculator, but I have already worked this out. With simplification, this is 243 over 2. Okay, and therefore, please go figure out how I found this. Therefore, your sequence, our first term, here's our first term, is 243 over 2. We can find our second term, it's AR, so that is 243 over 2 multiplied by -1 over 3. And we will find out that the answer is negative 81 over 2, -81 over 2, and the next term of course is 27 over 2. What I hate about this, and I'm gonna be honest, is that with this issue, when you have squared it with an even number, what I hate about it is you have to make many solutions. I really hate something that drags and you don't see where it's going. So now we're gonna follow the same procedure, but this time is if x is equals to 8, and I'm gonna be quick on this one because I assume that we already know. Well, here wherever we see x, we will now no longer put -1 over 2. We'll just put 8 minus 4, and of course our answer there is 4. For T5, instead of us putting -1 over 2, we will just put 8 plus 2, so that is 10. And of course for T6, instead of us putting -1 over 2, we will put 8, and that is plus 1. This is where I'm getting it, and our answer there should be 25. Okay, I'm not gonna labor that much on this. I'm already tired. Then again, we are solving for R. exactly the same, guys. We are gonna say T6 over T5, but instead of us now saying 1 over 2, we're gonna say 25, and then instead of us saying 3 over 2, we are then gonna say 10. All right, so that our answer is 5 over 2. Don't write it as 2,5, write 5 over 2, please. Then we can use the same procedure. That's why this is so, well, I won't say boring, but I really hate overworking. All right, I like getting to answers as they are, but anyway, it's fine. Same procedure. This then implies that AR to the exponent 5, and we must then find out what was our T6. Our T6 now is 25, no longer negative 1 over 2. This therefore implies, well, what is our A? I think, have you found our A? No, we haven't. We are looking for our A. Okay, so our R there, it's 5 over 2 to the exponent 5, which equals to 25. And if you solve that, please show all the steps. I'm skipping steps because now I'm kind of tired, but please show all the steps. Is equals to 32 over 125. And if you work that through, please do work it. That is your little homework. If you work that through, you'll find out that your sequence is 32 over 125, 16 over 25, and 8 over 25. What is critical here, guys, is that we were looking for the values of A and R. Okay, if you go through many practice questions like this, you should be more or less fine. All right.